Hello, calculus students. This is Ms. Orloff, and I am going to do a short video on the first day of limits, which you should have had some exposure within your pre-calculus class. So I want to first go over what do I mean by a limit. So a limit is, as the input value, we typically say x, but that input value, as it approaches a value, what is the output approaching? Keyword there is approaching. It does not need to equal. Okay. So we're going to take a look at a piecewise function. And you can see this piecewise function, which is simply just pieces of a bunch of different other functions to create one. One thing I want to bring up, these points that are outlined here in gray, we mean for them to be open, so they're not inclusive. Only the black points are the ones that are inclusive. So I want to make sure that you understand that. So if I look at a limit, one thing I need for you to try to recall from pre-calculus is, what does this notation mean? So when I look at something like this right here, as x approaches 2, and you've got that negative sign up there, and that means from the left. And a lot of students become confused with that. To the left means you are starting with a number smaller than 2 for x, and then you're going to approach it. So I'm going to start at like 1.9, and I'm going to approach 2. And I want to know, what does y equal? And so from the left, the y value, the output value, approaches 2. This limit here with this plus sign, the limit as x approaches 2 from the right. So you're starting at a number greater than 2, to the right of 2, and then you move towards 2. So you're really moving in a leftward direction, but you're starting to the right of 2. And so I'm going to move this way. Now, from the right, I'm approaching that gray point, which I've indicated means it's open, but it doesn't have to equal anything from that side. It just needs to approach it. And it is approaching 3. So I have this left-hand limit that exists, and I have this right-hand limit that exists. So the big question in number 3 is, does the limit as x approaches 2 of f of x exist? Does it equal anything? And my answer is, it does not exist. And the reason why it doesn't exist is because what is it going to be? Is it going to be 2? Is it going to be 3? The left-hand limit cannot contradict the right-hand limit. So for a limit to exist, the limit exists if and only if, but I'll simplify that to a when, the limit as x approaches some value c from the right of f of x. I'm going to use proper notation. You need that f of x. You cannot drop that off. Equals the limit as x approaches c from the left. If that is true, then I can say the limit exists. So we're going to go ahead and look at 4, 5, and 6 together in this video. So again, the limit as x approaches 4 from the left of f of x. So a number smaller than 4, like 3.9, and getting closer to 4, like when x is 3.99, 3.9999. So it's approaching 4 from that left. Does not have to equal a y value at 4, it just has to approach it. And so the limit as x approaches 4 from the left equals 1. The limit as x approaches 4 from the right of f of x also equals 1. So in this case, I can say the limit exists. Now I'm going to go ahead and spiral ahead a little bit right here, because this lends itself to a really good conversation. This will come up later, and it will be something that you'll have to think about on an AP test, is is f of x continuous at 4? So I know if you were given a graph that you guys can look at that, and after your experience in pre-calc, you can say, nope, Miss Orloff, man, that is just a removable discontinuity. In fact, I should not have said removable because of this value up here, but the function is not continuous. The way we prove that in calculus, and I'm not going to make us do that right now, is though the limit exists, does it equal f of 4? So like if I extended and said to you guys, hey, what's f of 4? Well, f of 4 is not 1. F of 4 is 3. So I just wanted to bring that up. What I'd like for you to do is pause this video and complete 7 through 12. After you've completed it, start the video again, and then check your work with me. So you should have had some time to work 7 through 12. Now 7, 8, 9 are pretty straightforward. The limit does exist. It's 10, 11, and 12. So on 10, that left-hand limit does exist, but there is no right-hand limit. We can't approach 8 from the right. So the big question is, so then does the limit exist? And by definition, we would say no. The good news is the College Board nor I will really try to trick you on that. They try to avoid endpoints and asking limits. But it is something that I want you to think about, because in this class, like no other, you are going to have to pay attention to the finest detail, one word in a direction that can change things for you. So we just went through a graphical approach to limits, and now I'd like to do a tabular approach to limits. How do I use a table to determine a limit? So I have this function. It's a rational function of x minus 3 all over the value of x. And I want to know the limit as x approaches 0 from the left by plugging in values of the left of 0. I apologize. So I'm going to start with numbers smaller than 0 and then approach it. I've already pre-placed this function into my calculator. So it's not a bad idea to pause your video now and kind of get that in there. So I have this in here, and I know different ways I can approach my table. So I'm going to do a really quick, let's talk about our table kind of feel. Currently, my table may be set at counting by 1. Well, that's not good enough. So I could do two things with my table. Before I continue, anytime I use this emulator, anytime I touch a button on my calculator, the last button I touched turned red. So I just hit the second key, and now I'm going to hit window for table set. I have two choices here. I can start this table at negative 0.1 and count by a certain value. This triangle here means change in table, or I can put it on ask, only the independent variable. So I'm going to do it this way. And now it gives me the freedom to just punch in values like negative 0.1, negative 0.01, negative 0.001, and we'll do one more, negative 0.001. And you can see those values. After looking at the values, I'm very comfortable saying the limit as x approaches 0 from the left of f of x is approaching infinity. Please pause the video and fill out the table to complete that limit as x approaches 0 from the right. So after filling out the table, I am comfortable saying that the limit as x approaches 0 from the right. This is not proper notation, by the way. This has no meaning to me. I need to put in that I am discussing the limit of f of x is negative infinity. What I'd like you to do is think about, does that limit exist? And I want you to write out why. Give me a justification. Tell me why. You're going to find in this course, you're going to have to write statements often, and you have to be very precise and specific. So I want you to think about what you would write about. So I can write this out in words. I can talk about f of x is increasing, becoming more and more positive as it gets closer to 0 or going more negative. But in calculus, we like really mathy statements. No, why? The limit as x approaches 0 from the left of f of x does not equal the limit as x approaches 0 from the right of f of x. That's the math statement, right? And by now, I think, you know, if I wanted to think about a graph of f of x, and this is truly a very generic graph, I think after a pre-calc course, you guys would kind of have that idea of knowing. I'm actually not a fan of what I just drew there because I would know where my horizontal asymptote was, but I would know that as x approaches 0 from the right, as it approaches 0 from the right, what happens, the values are going downward. They're going like this. And as x approaches 0 from the left, they're going upward like that. And we could talk later about the horizontal asymptotes and things like that. 16 through 23. I'm not going to go through all these examples. I'm going to talk about them. These are pretty straightforward. The one thing, the first step any student should ever make when making a limit, taking a limit algebraically, we should always, 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 always try substitution first. And if you get a constant value when you substitute, you're done. You don't have to do anything else. I can't drop the limit notation until I actually do that substitution, and I can do that substitution immediately here. And you can see me doing that. And if I get this constant value of 2, I'm done. That is the limit. There's certain situations where we have to do a little bit more, and I'm going to save that for tomorrow's conversation, the next video. But I'm going to ask you to pause the video, and I'd like you to do 17 through 21, and then we're going to save that trig stuff when we come back. So please pause the video. So here's my work. Please pause the video, check your work. If you are struggling with any of these answers, please make sure you bring that question to me the next time we meet in person or we have a virtual conference. The last two I can substitute in, but this is going to require you guys remembering some trigonometry. And I'm going to tell you, as I state all the time, calculus is the gathering of all the math you've learned before. You've got to know this. We are not reviewing it. So if you need help with that, talk to me. This is taking the limit of the inverse of cosine at 1. So what angle makes cosine 1? And that is 0. What I'd like you to do on these next two examples, I'd like for you to actually graph this guy. Not the limit, just that. Making sure you have parentheses here and parentheses there. And see if you can take a look at the graph and make a decision for yourself what that limit is. So here is the graph of problem number 24. And if I take a graphical approach, I know that as x approaches 0 from the left, y approaches 1, and from the right, it approaches 1. Therefore, the limit exists. Now, the value does not, but the limit exists there. So I'd like for you to graph 25 and tell me what you think. I got 1 for both. So what can you conclude? We're going to save that for my next video or a video in the future. I hope you all have a great day.